Okay, so we want to do numbers 20 and 21 out of 12.5. It really is kind of a question about what do we mean by equal signs. So number 20 in the instructions read, are f and g equal? If not, state why. Right? So is f equal g? Okay, so what I mean by is f equal g, right, is are these two things the same rule, right?
Right. Only if x is equal to 1. For those ones.
Careful. Okay, so let me think. All right, I've got 3 points for f. And then for g, I've got absolute value of x. Okay? How do I determine if two functions are equal? I want to know, do they act the same, right? In other words, are they the same rule? So, does this rule act like absolute value of x?
No,
Why?
it's got a negative in it.
You're taking an x and getting a y out, though.
Yeah, so these are ordered pairs, right? This is really them saying this is an x and this is an f of x, right? Or them saying maybe -7 goes to 7, 0 goes to 0, 8 goes to 8.
Okay, so if x is -7, the absolute value would be 7.
Yeah, you guys see that? This thing does act a bit like absolute value of x. Why aren't these two functions the same? So they do agree, right, at -7, 0, and 8. But does this rule f, does that thing know what to do with, say, x is 2? No, it has no idea. Does g?
Yes.
What's absolute value of 2?
2.
2.
But for
Okay.
f of x, it only has 3 points on the entire thing.
Yeah, and f doesn't know what the heck to do with it, right? You guys see that? So f is the absolute value of x, but with a restricted domain. You guys see that? This domain is restricted to -7, 0, and 8. It doesn't even know what to do with -8, right? So this thing isn't quite g, but it's a super restricted version of g. You guys see that? So for number 20, I would say f is not g. F has domain, right? And then I might even just list what's in there. So -7, 0, and 8. G has domain
Everything positive. 0 and up. 0
It can take any number.
Yeah, so domains, remember, are the inputs. Absolute value can take, regardless of positive or negative, any of the inputs. It outputs only positive things. I could use the outputs to actually argue this too. We could say f has range, right?
7, 0.
7, 0, 8, and g has range 0 to infinity. You guys see that? If they don't output the same stuff, they certainly couldn't be the same rule. You guys cool with that?
So G has all real numbers.
Yeah, the domain of G is all real numbers. The domain of F is only 3 points, or 3 x values. So these don't quite agree. They do happen to agree on those 3 x values, right? All right, so how about for 21? I've got f of x is x, and g of x is x cubed plus x over x squared plus 1.
Well, you know for a fact that they agree on x is 1.
Okay, so they agree when x is 1.
Well, you can
They
just
are
factor
equal
it.
though. If you, for the top of G, if you factor out a single x, you get x squared plus 1, and then they cancel, and then you just have x.
Okay, so why aren't you worried about a domain restriction there? So remember, when I cancel, right? I'd say, okay, this is X. And oftentimes I have to write, but I expanded the domain, right? Did I expand the domain on this one?
No, because x squared, it can only be something positive.
Good. X squared plus 1, right, is positive and bigger than 1. You guys see that? It doesn't have a 0, right? If I thought about x squared plus 1 as a parabola, it looks like this, right? It doesn't have any zeros. So there's no division by 0 concern here. So when I cancel these, it actually is equals here with no caveats or addendums. So what do I write?
Yes.
All right, yes. F equals G. You guys see that? They have the same domain, they have the same range. In fact, they're the exact same thing. The only difference is that I canceled something that can never be 0 anyway. You guys see that? Does that help, Josh?
Yes, that helps.